Okay, our next section is sampling error, and we're going to make a big point to compare sampling error to bias. So remember, we're using a sample to estimate the population. So basically, we have a sample statistic, and we want to know how well it measures the population parameter. And remember, we also said that a good sample looks like the population, and a biased sample or a bad sample overrepresents a portion of the population or underrepresents a portion of the population, typically in a systematic manner. So, sampling error. Sampling error is basically what we call sample variation, and is due to random chance. It can be described by a probability model and minimized by increasing the sample size. So this is a huge distinction between bias and sampling error. First off, it's due to random chance. It's not due to, so sampling error is due to random chance. It's not due to a bad design. It can be described by probability, and we can minimize it by increasing sample size, where we can't do anything to fix bias, right? Increasing sample size does not help bias, but it will help sample size. The reason we have sampling error is because the sample was used to estimate the population, all right? It's almost always going to be there. Matter of fact, we can just go out there and say this. It's always going to be there, and it's always going to be there because the sample is only population, all right? So, and that difference between the two is the sampling error. Here's why it exists. If we take the entire population of 3,400 students at Reagan and I put all their names in a hat, I think we could agree that everyone would have an equal chance of being selected. So basically, that's pretty random, and there was no system error when I draw the names. But it's possible that I could draw draw 20 names, and no seniors be represented. That's possible. And consequently, that would be sampling error because I didn't have them represented proportionally or represented at all. It's possible you go, well, what if you drew a bigger sample? Let's just say you drew 340 or 10%. Well, that's a pretty good size sample. But what happens if I did that? I should have about 85 names for every grade level represented. Well, if I only had 40 of one, then they were underrepresented. Again, that's sampling error, where the sample statistic was different than the population parameter. Or think of it this way. If I put 3,400 names in a hat and drew, and then had you draw and someone else draw, are our samples going to be the same? And the answer is no, they're not. So we know that there's going to be variation, all right? However, we feel a little bit more comfortable if I had 340 people draw than if we only had 20 draw. What if I had 1,000 draw? You're like, well, you know what? That's probably even more likely to be measured correctly. And what happens if I had all but one? I had 3,399 draw. Well, the fact of the matter is, it would still be an estimate. We'd feel pretty good about it for sure, because sampling error is diminished when we increase the sample size. But we still would be missing out one person, and as such, the population proportion, or our sample proportion, would differ from the population proportion, maybe only slightly, but it would differ. So basically, sampling error is random. It randomly happens. It always happens. We're actually okay with it occurring. We can not eliminate it, but we can decrease its effects by increasing sample size. And the reason it exists is sampling error or sampling variation occurs because we're using a sample or a portion of the population to estimate the whole population. So our sample is an estimate of our population. Because it's only an estimate, we have error. We talk about this error all the time, especially during an election year. We say someone has 42% of the vote, plus or minus 3.5%. That plus or minus 3.5% is an acknowledgement of the error. We actually know how to calculate it. We will calculate it later this year. It's very, very easy to do. It's just beyond the part at this point. But the error term, we know how to describe how likely it is to happen. With bias, we don't know what we have because we have a bad design. So sampling error, we can deal with. It's not a big issue. It's not the same as bias. Bias cannot be fixed by increasing sample size. Sampling error cannot be eliminated, but it can be diminished, and it only happens because we're using a portion of the population or a sample statistic to estimate the entire population.